Hi everyone. In this video, I'm gonna present CodeGraph, a web interface presentation or implementation of programming knowledge graph papers. In programming knowledge graph paper, the authors basically try to propose a programming knowledge graph over a code-centric data source or data set. Basically, in a main paper, for generating a programming knowledge graph, we need to proceed 6 steps. The first step is to choose a programming dataset. The next step is to extract the functions using some function analyzer. The next step is to extract the code blocks, which is done by AST or three-seater if the programming languages is something except Python. The next step is enhance PKG using some descriptions, which is done by another LLM. This step somehow optional because if we have some limitation regarding the computational source, so we could ignore this part. The next part is encoding the PKG. By encoding the PKG, we mean changing or providing the embedding representation of each code block. And the next step is to convert all of these steps or all of these resources, I mean the nodes and relations and the embeddings to a Neo4j graph. So as you can see, building a PKG involves several steps. In this tool, we are trying to make it more easier. So basically, this CodeGraph web interface consists of 2 parts in Playground. So the first part is a visualization of the PKG. As you can see, this graph consists of almost 50,000 nodes, which is not the complete representation of the PKG. So basically, we took Python alpaca dataset and then extract the Python codes and then extract the code blocks and try to generate a knowledge graph out of those contents. The main graph consists of around 400,000 nodes with their relations, but here we only show a small portion of the main graph, and basically the nodes are located to each other based on their similarity. So if I want to explain or go through some of these nodes, we can see, for example, here we have find max node, which is a function name, and it has also several implementation. For example, here we can see the content of the implementation content of that. Here we can see another implementation. So basically, in terms of node types, we have function name, we have code blocks, which contains the implementation, and also we have docker strings. Other than graph visualization, we also provide a retrieval part over this PKG. So basically, in retrieval, you can write some queries or write some problem statement, and then this problem statement would be converted to embeddings, and then a vector semantic search is done over the PKG, and then the most relevant code blocks or contents would be returned as an output for this section. So for visualization, I'm gonna take some of the human eval problems to see what is the performance of the PKG. Okay, for example, this problem is regarding a string representation. We need to parse a string representing multiple groups of nested parentheses, and the problem aims to return a list of deepest level of nesting for each group. If I click the search, it will go through the graph, and then you can see we have several results out of this PKG. Basically, the results are sorted based on their similarity score. So the embedding of this code is the most similar embedding to this explanation. So it would be presented first, and we could see the other similar other less similar results in the following. Let's take another look. For example, here we have basically the problem is about a function for finding 0, which should find the 0 point of a polynomial with given coefficients. I'm gonna copy this description and then paste it here, and I'm gonna ask the PKG to find the most similar code contents. As you can see, the PKG would be able to extract the most precise code blocks. The advantage of PKG over a normal RAG is that in normal RAG, basically the contents is split based on paragraphs, based on question answering pairs, based on a content block. But here the retrieval is done or conducted based on code blocks, and it tries to find the most similar path and try to prune the paths in the code that are not similar to the query. And for example, here what we are seeing is the most similar code path out of this graph. Thank you so much. If you have any question, please let me know in the comments.